Assalamualaikum warahmatullahi wabarakatuh. My name is Sofiyyah Farhana from class laboratory 2A, and today I'm going to present the journey of my mini project. The project I created is a touch sensor LED keychain. There are 4 main steps in making this keychain. First, 3D designing. Second, PCB design. Third, 3D printing. And lastly, soldering. Let's go through this one step at a time. First, for the 3D design, I used Cuttle.xyz to design the font for the keychain. I chose Cuttle.xyz because it's easier to use existing fonts rather than manually sketching, which is time consuming. I also added an outline stroke to the font so that when we design the 3D model, it creates a container-like structure for the circuit. Another reason I used Cuttle.xyz is that it can export the design as a DXF file, which is the only format accepted by Onshape. After that, I opened Onshape and imported the font file I created earlier. Then, I added a sketch for the keychain and extruded each parts of the model. I extruded the base and the border with different thicknesses. The border serves as the container, while the font area without the border forms the base. Once the 3D model was ready, I exported it in STL format, which is required for the next step. Next, I worked on designing the PCB layout for the touch sensor LED. For this, I used Proteus to design both the circuit and the PCB board. Once the design was complete, I generated a Gerber file, but for this project, we didn't use the design we made. Instead, we used a ready-made PCB board. Then came the 3D printing process. I imported the STL file into Ultimaker Cura, which converts it into G-code for the printer. After importing, I checked that the model was in the correct size and scale. Then, I flipped the model upside down so the printer would start printing from the base. I added a feature called Pause at Height at layer 5, allowing me to change the filament color. Before slicing, I turned on the support feature to ensure parts that didn't touch the print bed would print properly without sagging. Then, I sliced the file and saved the G-code onto an SD card. For the actual printing, I used the Creality Ender V3SE printer, which matched the printer type set in Cura. Before printing, I followed proper procedures such as preheating the printer and cutting the filament at a 45-degree angle. After printing was completed, I removed the support structure, which came off easily. Now, the 3D model was complete and ready for assembly. Finally, I moved on to soldering, which was the most exciting part. Before I start soldering, I made sure to check the polarity of the battery holder and the LED to avoid connection issues. First, I connected the VCC pin on the PCB to the positive terminal of the battery holder. Then, I connected the I/O pin to the positive terminal of the LED. Lastly, I soldered the ground pin from the PCB to both the negative terminal of the battery holder and the LED. For some parts where direct soldering wasn't possible, I used jumper wires. At first, the circuit didn't function properly. Upon inspection, I discovered that some jumper wires were touching each other, causing a short circuit. I resoldered those parts and thankfully, the circuit started working as intended. Although I faced some challenges like a broken LED or the LED not fitting perfectly into the container, I managed to fix the issue and complete the project successfully. Here's a quick demonstration. As we can see here, when I touch the sensor area, the LED lights up. That's all from me. Thank you for watching. Bye!